Hello everyone, we are back again with more polynomial fun, and today we are going to be looking a little bit more in depth at multiplying polynomials. Now I know we've talked about multiplying polynomials so far, where we've multiplied like a monomial such as x by a binomial such as x plus 2. We've also looked into a binomial times a binomial, so if you had something like x plus 2 times x minus 4, let's say, we've talked about how to multiply or expand that, and then we've even took that a step further and said, well, what happens if it's not just 1x? What happens if it's like 2x plus, say 4 times negative 3x plus 2, or whatever have you. And what we've discovered is that in all three cases, although the numbers change a little bit and there might be a little bit more to multiplying in particular these bottom two things together, or expanding these two, than there was with expanding this top guy here, the rules stayed the same, right? And that's kind of nice. And no matter how many terms one of your factors has, the rules are still consistent, right? We can still follow them. So we're going to look at an example or two today on, well, what happens if there's three terms in here? What does that look like? What does the rectangle diagram look like? And what does the distributive property look like with that? So with that being said, let's clear the board here and let's get started. And we're just going to simply title this multiplying polynomials. Right? And let's just get started right away with some kind of example here. So let's say we have 2x plus 5, and we're going to multiply that by a trinomial. So let's say x squared plus 3x minus 4. Let's say we're going to do that. Now, method 1, similar to other videos, we're going to use the rectangle diagram. Right? So for this one, we are simply going to make a diagram here. That is a rectangle. Now, in this case, how we divide this up is going to be a little bit different. Right? I'm going to make it kind of bigger. And since there's two terms here, I'm going to make two rows. But since there's three terms here, I'm actually going to make three columns. Let's make that a little bit more even. Divide that there. And something like that is fine. So for the, let's color code these again. Let's make an orange and a yellow side, the same thing as in the other videos. And for our 2x plus 5, we'll put our 2x there and our plus 5 there. And then since there's three terms here, we've got three columns now, so we're going to do something similar. We're going to have our x squared here, and you might even notice we've got an x squared here. It's not just an x, but that's okay. That doesn't change the rules. And we've got a 3x, and then we've got a minus 4 down there. So when we go to multiply all these together, again, the same rules apply. That's what makes this so nice. So we're just going to go ahead and multiply all these together. So 2x times x squared, well, again, we treat the coefficients like they're their own separate thing to get the new coefficient, and then we treat the variables like their own separate thing to get the new variable. So the coefficient for the x squared is invisible. It's one of those invisible ones, right? So 2 times 1 is just 2, and then x times x squared is x cubed. Let's keep on trucking. So now we've got 2x times 3x. Again, multiply the coefficients. 2 times 3 is 6, and then x times x is our x squared. And then similarly, 2x times negative 4 is negative 8x, right? And now we can go ahead and do the bottom row. So 5 times x squared is just 5x squared. This is kind of nice. 5 times 3x is 15x, and then 5 times negative 4 is negative 20. So we can go ahead and rewrite this up here. And we can say, well, that 2x plus 5 times x squared plus 3x, take away 4, is the same as saying, well, 2x cubed, or it's equal to 2x cubed plus 6x squared, take away 8x plus 5x squared, plus 15x minus 20. And then we can highlight some like terms here. We've got x squared there, we've got x squared there, and then we've also got we have 8x there and then 15x there. So we've got some like terms here, so we can go ahead and combine those. So that all equals 2x cubed, 15 and 6, or sorry, 6x squared plus 5x squared is 11x squared, and then minus 8x plus 15 leaves us with plus 7x, and then our minus 20 is left over. So that is one strategy to multiply that polynomial. So again, just because there's three terms here, the methodology stays the same. It just, you add a little bit more to it to accommodate the extra term, but apart from that, the rules don't change, right? And that is the same thing when we go ahead onto our method 2 and talk about the distributive property. Right? Where we multiply every term in this, in the first polynomial, by every term in the second polynomial. So that's like 2x times all that plus 5x times all that, right? And that's what we're going to do. So let's rewrite this down here. So we've got 2x plus 5 times x squared plus 3x minus 4. We can rewrite this. We can say, well, that's like 2x times all of that plus 5 times all of that again. Right, and that's going to leave us with, and we can just multiply each of these through. So 2x times x squared gets us 2x cubed. 2x times 3x gets us 6x squared. 2x times negative 4 gets us negative 8x. And then plus our 5. 5 times x squared is just 5x squared. 5 times 3x gets us 15x, and then 5 times minus 4 gets us our minus 20. And then once again, we have our like terms here, right? It's actually even in the same order as up there, coincidentally. And then we're left with our 2x cubed plus 11x squared minus 7x minus 20. It's the same answer up there, very consistent, which makes sense because it's the same problem. So again, the same strategy is what we've used this whole time. It doesn't change now just because we're talking about products that happen to have a higher order or higher degree rather, or or we're talking about products that involve more than just two terms in one of the factors. Again, the rules do not change just because this looks a little bit more complicated. More steps are added, but the level of difficulty doesn't really change a whole lot. So please don't let the bigger polynomials frighten you, or the weird wonky numbers. If we've got negative numbers in there, if you want to get really crazy, you could get decimals or fractions as coefficients as well. Again, the rules don't change. So that being said, I hope that all makes sense. If you have any questions, please feel free to reach out. As always, I hope you are all doing extremely well and that you are staying safe. Have a good one.